Today you'll be seeing Experiment 6, Chemical Equilibrium, presented by yours truly, Braden Lazara. The objective of this lab was to determine how changes in concentration of reactants and products affect chemical equilibrium and gain additional experience in interpreting chemical reactions. Here's a little background info on Experiment 6. Reactions are in a state of equilibrium. There could be more or less products/reactants, but the process occurs at the same rate. And finally, equilibrium can be shifted by applying stresses. Lila Letcher's principle explains what will occur in a reaction when stresses are added. The stresses explored in Experiment 6 include pressure change, temperature change, and concentration change. There were a total of 6 experiments conducted, but this video will explain the last 3 being Experiment D, E, and F. The equation on the screen represents the equilibrium equation for Experiment D. COH2O6 2+ had a pink color in the experiment. COCl4 2- had a blue color in the experiment. The first stress added was HCl. When this was added, it increased the concentration of Cl-, which ultimately caused a shift to the right. This shift led to a deeper blue. The next stress added was an increase in temperature. When the temperature increase took place, the solution turned once again to a deeper blue. This would make the reaction endothermic because a shift to the right occurred when temperature increased. The final stress in Experiment D was a decrease in temperature. Knowing that the reaction is endothermic, a shift to the left would occur, which caused the color change to be purple. This slide exhibits the observations made in Experiment D. The equation on the screen represents the equilibrium equation for Experiment E. In Experiment E, Fe3+ had a yellow color, SCN- was colorless, and FeSCN2+ had a red blood color. When FeNO3 and KSCN were mixed, the result was an orangish red. The first stress added to Experiment E was a temperature increase. When this occurred, the solution turned a lighter orange. This would make the reaction exothermic, and a shift to the left occurred. The next 2 stresses were adding excess reactants. When both were added, it resulted in a shift to the right and a darker red. The final stress added was the addition of AgNO3. When this was added, a solid product was formed being Ag+ and Cl-, and the solution became a creamy white. This would mean the reaction shifted left to reach equilibrium once again. This slide exhibits the observations made in Experiment E. The equation on the screen represents the equilibrium equation for Experiment F. The stress added to Experiment F was an aspiration vacuum. This tool is used to take all of the gas out of the equilibrium. This would lead to CO2 being decreased since it is the only gas in the equilibrium equation. This decrease would cause a shift of the concentration to the left. When the shift occurred, it changed from green to blue. In the lab manual, it stated what the pH of each color meant. As illustrated on the screen, the solution went from neutral to basic because of the shift from green to blue. This slide exhibits the observations made in Experiment F. Thank you for taking this chemistry ride with me, and here are my resources consulted.